Okay, this is 8M4, lesson 15, the slope of a non-vertical, non-horizontal, well, non-vertical line. So we talked yesterday in lesson 14 about horizontal lines and vertical lines. Today we're going to talk about lines that are everywhere, kind of in between those two. So let's hit the sketch pad and see what we can figure out about non-vertical lines and slopes. So we're going to build a little bit. We're going to start talking simply about positive and negative slopes. Make sure we understand that concept. Then we're going to move into steepness of slopes and how you calculate slopes, and we're going to be rocking and rolling by the time this lesson is done. So the first thing we want to know is what is a positive slope and recognizing a negative slope. And so that's going to be, we're going to look at these 7 graphs and we're going to begin to understand those concepts. So a positive slope is, and we're always looking as we read left to right. So as you look, left to right, ask yourself, does the line go up or down? And if it goes up, we have a positive slope. We call it a positive slope. And if it goes down, we have a negative slope. We'll see more later on when we calculate these things, why this is true. So if we go up, like here in A, we go up as we go left to right. We go up from left to right. Notice up. So this is a positive slope. We call this positive slope. Now, let's see if we can identify the first line that is a negative slope, which is the first line that goes down as we go from left to right. And for those of you who identified C is a negative slope, this is the first negative slope because we go down from left to right. And as we go from left to right, we are going down. So why don't you just make sure that you understand, and it doesn't matter how steep the line is. If it's a shallow line like this one and goes up left to right, or a steep one like this or whatever, it doesn't matter. We're just talking about positive and negative. We're not talking about how big it is yet. So why don't you pause and try. Okay, so pause and try, and then come back. Okay, I assume you're back. Now, we'll just put a big positive here, because that's positive, and this one was negative. So is B positive or negative? Well, B is, for those of you who said positive, you are right, because it goes up. So this is positive. D is negative. E, even though it's really shallow or really slight, it does go up from left to right. So this is a positive slope. Positive. As is F. F is also positive. Very steep slope. But it is positive. Positive. And then G is negative. Okay, hopefully you got these right. You got the idea of positive and negative. Let's go, and we're going to look, and we're going to talk a little bit more about steepness here on the next page. And this should be hopefully not so hard for you. Let's take a look. So let's talk about so A and B, we've both identified these as positive slopes. Which one is steeper? A or B? Which is steeper? Well, if you were to climb a hill, think about climbing a hill. Which one is going to be harder to climb? And so that's going to be your steeper slope. So if you're comparing A and B, A is steeper. A is steeper than B. In other words, A has a greater slope. That's what we're talking about, a greater slope than B. A is steeper than B. It's got a greater slope than B. So let's look at C and D. For negative, two negatives. These are both negatives. Which one is steeper? Which one, if you put a rock on it and it starts rolling down, which one's going to start rolling down faster? If you were walking down a hill, which one would you be able to run faster down? Which one is steeper? And for those of you who say D, you'd say D is steeper. It's a steeper mountain. It's steeper than C. Yeah, D is steeper. It's going to have a greater, it's going to have we'll talk about that in a little bit, but it will have a greater absolute value for its slope. D is steeper than C. So this is what we talk about when we talk about steepness of slope. And we're going to put some numbers on this real quick. So just make sure you understand positive and negative, and then just kind of a sense of steepness. And let's go talk about that as we move along here. Now we're going to calculate slopes of these two lines. Now we said, and I just put some points on and I labeled the points. Notice how I labeled -2, -6, -2, -4, 4, and -2, 6 here. And likewise, on a separate line, I labeled these points 7, 6, 6, 3, and 5, 0. Now, the way that you calculate the slope, and this is something that's really important, and we're going to connect it back to some past learning in a little bit. But the way that you calculate slope is there's a number of concepts that you'll hear in math. One is called slope. And that has to do with how steep this line is and whether it's positive or negative. And that is also equal to the rise. Some teachers will say rise over run. And I like this concept, the rise over run. Others will say the change in y over the change in x. And that's also shortened to delta. They call it delta y over delta x. And all delta is, it's a Greek letter. It's a Greek letter that was adopted into math, meaning difference, change, how much something changes, or difference. Those are synonyms. The change, if something goes from 3 to 4, right? A change of 3 to 4 is the same thing as the difference between 3 and 4, which is 1, right? So the change from 4 to 7 is, if something goes from 4 to 7, it's the same thing as 7 minus 4, which is a difference, right? Negative is difference. So change means difference. The change from 4 to 7 is 3. 7 minus 4 is 3. Same thing. Okay. Okay, so given this definition, rise over run basically means the same thing as the change in y over the change in x. And we'll see that here in a second. So let's look at these two lines. Let's first look at this line here. We're going to take a look at this line on the right. We're going to look at this line. Now, when you calculate slope, you can use any one of these formulas, and you can choose, the first thing you do is you choose any 2 points to look at. When we're investigating what's going on this line, you can choose any 2 points. Okay, that's the first step. So I'm going to look at this point, this 7, 6 point, and this 5, 0 point. We're going to look at these two. I could have chose 6, 3, but I'm just happening to choose these. It'll work out the same for any one of them. And what I'm going to do is I'm going to look at the rise. So I'm going to see how far does this line rise between these 2 points. We're going to look at the rise between the 2 points. And it could go down, but in this case, it goes up. So we're going to look at the rise. The rise is this amount, right? It rose from 0 up here to 6, right? If we're going from this point to this point, we're just the rise part. In this case, 0 to 6. 0 to 6. And then we're going to look at what we call the run. So how far do we, another way to say that is how far do we run to the right? We always run to the right. And so when we run, we go this far in this case. So we rose, which is straight up. We rose 6. We rose 6, which is, right? We're going to take our walk. And the way that you can calculate this also is you can, find your change in y. The rise is the exact same thing as the change in y. So the change in y is 6 minus 0, which equals 6. Right? So you either can count them out by 6, or you can subtract your y's, which is 6. Similarly, we ran to the right. How far did we go? We went from 5 to 7, and that's 2. We ran to the right 2. And so you can calculate that by finding your difference in x's. 7 minus 5 equals 2. Now notice, our rise equals 6. Our change in y equals 6. Our run is equal to 2, which is the same as our delta x equals 2. Same thing. So if you want to think about it as rise or run, you can. Change in y over change in x, you can do that too. Now, to find the slope, the last thing we have to do, C, is we have to divide our rise by our run, or delta y over delta x. And then we typically, and then D, okay, well, let's just do that. 6 over 2. And then step D is we simplify. And usually leave as fraction or integer. We don't leave it as a decimal if we can. So we're going to simplify this. 6 over 2 is equal to 3 over 1. And then because that's an integer, we can leave that as a 3. So our slope is a 3. So this line has a slope of 3. Now, notice there's another word or another code letter that we use for slope, which is called M. So sometimes you'll see slope represented by the letter M, and I don't know why. One of these days, or if someone wants to look it up in Wikipedia and put it on the blog for YouTube, you can do that. Why is slope M? I always mean to look that up, and I never do, but that's what mathematicians use as slope. So we have our strategy, and now we can do the same strategy. Notice what will happen. If we chose 2 other points, we would get the exact same thing. And watch how this works. We're going to use these 2 points instead. And we're going to see that we'll always get the same slope. So I'm going to subtract, I'm going to find my rise. My rise here is a 3, and I'm going to run 1, right? If I do this triangle between these 2 points, so I'd say rise is equal to 6 minus 3, and my run is equal to 7 minus 6. So that's a 3 for my rise and a 1 for my run. And so my slope, M, is equal to my rise divided by my run, or 3. notice if I would use 7, 6, or 6, 3, and 5, 0, I would also get 3. So it doesn't matter. Choose any 2 points on a straight line. It will always have the same slope. Now, let's just quickly run through this other example over here and look at the slope of this line. Well, let's choose these 2 points. And maybe you want to try this on your own. You can pause plus try if you want to on your own and see if you can find the slope of this line on the left. Okay, so let's use our rise and our run. We rise 1, 2, 3, 4. Sorry, it's kind of messy here, but if you see it, we go 1, 2, 3, 4, and we're going to run 4. We go up 4 and over 4. So our rise is equal to 4. You could have calculated it by saying 6 minus 2, subtracting your y's. Y is always on top. And your run is equal to 4, which is equal to, watch this. We subtract our x's, -2 minus a -6. Uh-oh, those negatives are a pain, but we switch to a positive, and subtracting a negative, like adding a positive, and so we also get 4. So our rise over our run is equal to 4 over 4, which is equal to 1. So our slope in this case is a 1. So this has a slope of 1. We'll do some more examples on our homework help. Now notice, this line is steeper. One last thing to connect back. Which line here is steeper? Right? The answer is, this one is, this line here is steeper. And so we expected, because it was steeper, it would have a bigger slope. And it does. It has a slope of 3, and this had a slope of 1. So this is our steeper line. And if a line is steeper, it should have a bigger absolute value for the slope. Okay, so I want you to make sure you have this strategy down, written down here on the right, because we're going to go into some homework help right now. And you're going to need to find the slope, calculate the slope of these lines. And again, I'll give you the clue here. Rise over run, which is equal to delta y over delta x. And notice this one here is going to be negative. Watch. B, hint, this one's negative. And C is a teaser. But I think you can get it if you stick to the formula of change in y over change in x. Okay, I will let you pause and try. Okay. I assume you're back. So let's just go to it. Let's go, we'll go to delta y over delta x, and we should be able to find all of these. You can choose any 2 points, but I'm going to choose the easiest 2 points. I'm going to choose these 2 points. I'm not going to use this point because it has a negative number, and I don't like dealing with negatives if I don't have to. So our change in y is 2 minus 1. Our change in x is 7 minus 5. And so we get a 1 over 2. There, we have a fraction for our slope. It's 1/2. Up 1 over 2. And we don't write that as a decimal. We leave it as a fraction because it's easier. Okay, now this one's interesting. So when we talk about rise over run, this has a negative slope. Notice. We rise, we actually don't rise, we fall 2. So this is a -2, and here we run to the right, we go 1, 2, 3, 4, 5, 6. So our change in y over our change in x is a negative 2 over 6, but we can also get it by calculating our change in y, which is 2 minus 4, 2 minus 4 over 3 minus negative 3. Notice we're going to get negative 2 over 6 down here, but we're going to do it both ways by just doing rise over run by just looking at it, and then also by calculation. So this is negative 2 on top, and on bottom we get a 3 plus 3, we get 6. Now let's simplify this. We can divide both by 2 and we get negative 1/3. Right, and so we expect this to have a negative slope because it's going down, and that's good. This one's going up, so we have a positive slope. This one's going down, so we have our negative slope. And here's our teaser. Kind of weird. We don't rise or run at all. So what's going on? What's our delta y? And what's our delta x? Let's stick to the numbers. Our change in y is our 5 minus 5. That's our change in y, which is crazy. It's 0. Our change in x is 7 minus 0, or 7. And what is the simplified 0 over 7? It's simply 0. So one key piece of learning is that horizontal lines have a slope of 0. And that kind of makes sense, right? Because positive slopes go up from left to right, negative slopes go down from left to right. So what's between negative and positive? Well, between negative and positive is 0. So you kind of expect that you should be able to get a 0 slope when you think about it. You know what? Let's do a happy cat for a happy cow. What? Where did the cow come from? Where's happy cat? Happy cat, happy cat. Someone help me out. Happy cat. That's confused cat. Happy cat? No. Happy cat? Happy cat. Where is happy cat? Oh, there's happy cat. Oh, thank goodness. Happy cat. Okay, let's move along. So on your homework, they pull this out. Oh my goodness. They go back to lesson 11 on the homework, something you didn't maybe do even in class today. And they say that they want to connect what we've been doing today to what we did a few days ago. But this is not so bad. And all you have to remember on your homework is that rates and slopes are the same thing. Rates and slopes are the same thing. So if I find slope, I know the rate. If I find slope, I know the rate. So how does that work? Well, let's find the slope. So here is a problem that says, what rate do I bake cakes at if the graph on the right represents the number of cakes I bake per minute? Well, you know how to find the slope. You know how to find slope. So you know the rate. Exclamation point. Very cool. So notice that we have another point on this line. It's 0 minutes, I have 0 cakes. So here's the hidden point. It's 0, 0. So I make 240 cakes, 240 minutes. I make 7 cakes. So what I need to do is find, this is my y and this is my x. And so I need to find my delta y over my delta x. Well, my delta y is 7. My delta x is 240. So I can get out my calculator just to see how many cakes I make per minute. And the answer is about, I'm going to round it, it's about 0.03 cakes per minute. I don't make a whole cake. I make a lot less than a cake. But in 1 minute, I make 0.03 cakes. You're going to use similar math on the last problems on your homework set if your teacher assigns the last problems on lesson 15. But this is the strategy you're going to use. You're going to find 2 points. You don't always get 0, 0, but you're going to take 2 points on the line and you're going to calculate the slope, and that's going to be the rate at which you are doing something, baking cakes, saving money, collecting water, filling a bucket, or anything. So this is the whole connection to lesson 11, and the whole thing, remember, rate equals slopes, and that deserves a happy cat. Let's now wind up this lesson, and I'll say goodbye. And we learned a ton today. Calculating slopes is very important. We're going to be building on this as we move forward. And good luck with your homework, and I'll see you next time with lesson 16.